Okay, solve the inequality. Let's take a look. This is number 21. Yeah, 21. Let's take a look. What do you get over here? X plus 1. I'm going to get one term. And what do you get there? You get x plus 6 minus 2x minus 2. X plus 1. And that's going to be what? 4 minus x. Okay, next up, number line goes down. What goes on the number line? Numbers. What numbers go there? Minus 1. And the other number is the number 4. The next thing I'm going to do is test it out. And I would take a number after 4, like 5, plug it in. It's going to be a negative number, so that doesn't get shaded in. A number between minus 1 and 4, like 0, plug it in. You can get a positive number, so that satisfies it right over here. Take a number below minus 1, like minus 2, plug it in. You're going to get a negative number, which are not greater than 0. The only other question is when is it equal to 0? Only at the number 4. All right? So solve the inequality. I did the graph of it. To solve the inequality, you could use an interval notation. It goes from minus 1 up to 4. That's typically what we do in class, by the way. You could also write down the intervals here. The interval for this thing would be minus 1 up to and including 4. Either answer is sufficient. Let's go to the next question. The next question says, which of the following functions could be that graph over there? One thing I noticed, it's exponential in form. All right, so looking at it, I know there's going to be an asymptote over here. It looks like y equals 3. So the first thing I do is go look at these things over here. And I'm looking at, two candidates where I see a 3 in it. Right, and the question is, what would you do now? I mean, maybe you take a point over here. And the point I would choose, by the way, I'm looking at these two over here. All right. Now, by the way, I know this one's out of the question. I'll tell you why. That one goes like this over here. It goes up. This one is a more likely candidate. Let's plug it in for you. What do you get over here? Let's see, 1/2 to the 0. Well, 1/2 to the 0 is just 1, right? And 1 plus 3 is 4. Wow, that works out beautifully. So at 0, this does give me 4. So this is the answer over here. The answer is A. Again, it's exponential. This is 1/2. It's a falling problem like this over here. It's asymptotic with y equals 3. All right, that's letter A. Let's go to the next one. The next one is a limit problem. And the way we've been doing these in classroom is we put a line down and we put the zeros down in the problem. And the zeros for this problem at the bottom would just be a plus or minus 1. What I notice about the top, though, the top is always positive. All right, look at the discriminant of that. The discriminant of the top is going to be 9 minus 4 times 1 times 5, which is 20. It's negative. So it's always positive. So what do? I'm going to go to the left of 1. That's right over here. Take a test point, like 0, plug it in. What do you get there? Plug in 0, you get positive on top and a negative on bottom, negative overall. Now this is a division by 0 problem, which means it's going to be minus infinity. All right? That's done. All right, let's go to the next one. Next one is for what positive values of x does h of x equal 3? Well, let's write down 3 equals log base 2 x squared plus 2. I'm going to rewrite the log as an exponential. That's 2 cubed. I'm sorry, 2 to the third power, or 2 cubed, is x squared plus 2. What's 2 cubed is 8, x squared plus 2. Well, take 2 from both sides, you get 6 equals x squared. What does this tell me? X could be equal to plus or minus the square root of 6. However, they did say what positive value. The positive value is the root of 6. That's letter D. All right, the next one says solve algebraically exact answers. And let's write this down now. So it's 5, the natural log of 3x equals 20. How did I do that? I added 2 to both sides. Divide through by 5 now, and you get 4. Rewrite the log as an exponential. That means 3x equals e to the 4. And then divide both sides by 3. And you get e to the 4 over 3. All right, that one's done. That's not so bad. So e to the 4 divided by 3. Let's go to the next one. Next one's multiple choice. They want to know what x is. And let's write this down. So 3, x plus 5. This looks strange to me, but I noticed that 27 is related to 3, so it's really 3 to the third power. That's raised to the minus 1, which is going to be 3 to the minus 3. What does that give me? X plus 5 is minus 3, x equals minus 8. What choice is that? Letter B. We're done with that. This one's a condensation problem, and they do it, a variety of ways of doing it, but I'm going to work inside the grouping symbol first. So 1/3, this can be natural log of x plus 3 squared plus the natural log of x minus the natural log of x squared minus 1. The next thing I would do, I'm just using rules of logs. I'm going to do the inside now. What do you get there? ln x plus 3 squared. I'm just doing one step at a time, times x. I just did these two terms over here, minus the natural log of x squared minus 1. I'm going to keep moving. It's 1/3. I'm still on the inside. It's the natural log. I see a division now. It's going to be x plus 3 squared over x squared minus 1. Now again, this is about it, but if you want to, you can bring the third in there. And if you want, it's just going to be 1/3 natural log of x plus 3 squared over x squared minus 1. This is sufficient, by the way. You can also rewrite it, if you like, as a cube root problem. The natural log, the cube root of x plus 3 squared over x squared minus 1. All right? Let's do the next one, number 23. Number 23 says use long division. And let's break this down then. So x minus 5. And write this down as x cubed minus 5x squared plus 9x minus 45. Well, I'm going to say what times x cubed is x squared. And what do you get there? X cubed minus 5x squared. Well, that's convenient, because when I subtract that, they disappear. I'm left off with 9x minus 45. Well, what times x give you 9x? It's just going to be plus 9. What does it give you? 9x minus 45, remainder 0. So what are we looking for? X squared plus 9. That's letter A. All right, that's good. Next one. The next one is, what are the equations of the horizontal asymptotes? You must show work. All right, so what I want to do is, what we've always started with is a number line. And the number line, the first thing I put down is, 1. That comes from the bottom. 1 makes the bottom 0. Minus 3, that comes from the bottom. The next thing I want to do is the top one that becomes 0, that's at minus 1. All right? I'm going to keep going through it. I'm looking at, the 3x minus 4, and 3x minus 4 becomes 0, or just over here, when 3x equals 4. And that's going to be when x equals 4/3. I hope you realize that 4/3 is above 1. All right? Okay. This one says, what's the horizontal asymptotes? That's when the limit... Oh, I forgot to put this on. I'll put them down later, by the way. X goes to infinity of f of x. Well, hopefully you've done enough of these to start to realize that leading coefficients, it's just going to be 3 over 1, which is 3. And if you go to minus infinity, again, just the coefficients, it's still going to be 3. What does that mean? This implies the horizontal asymptote, that's an equal sign. Horizontal is y equals 3. That's done. Let me go back to the sign analysis. I forgot to do that for you. But let's take a look at this. I'm going to use numbers above 4/3, like 10. Plug it in, you get positives everywhere. Which I'll say that it's not a bad thing to be able to do arithmetic quickly. And you pick numbers that are convenient for you. I realize between 1 and 4/3 you might be struggling with it, but let's just move on to a different interval. Between minus 1 and pick 0, what are you going to get? You still get positive. Again, I chose 0 there. Now, between minus 3 and minus 1, I would probably choose minus 2. And if you plug that in, a little more complicated, isn't it? So I'll write this one down. If I chose minus 2, looking at it, you get a negative. I'm doing the top now. You get a negative. On the bottom, what do you get? A positive and a negative. What does that give me? A negative overall. Right, not so bad. If I took a number below minus 3, like minus 10, I plugged it in, you get negative, 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 negative. That's positive overall. Now, granted, I realize this might seem difficult to you, but I'm going to choose the number 1.1. If you plug it in, what do you get? Well, you're going to get negative. Let's say you can get positive. Doing 1.1, you get positive. And on bottom, 1.1 minus 1 is a positive number. So for roll, I get negative. Now, someone says, why would you actually do that? The reason for that is the limits become much easier for me now. So there's going to be two limits I do. And it's going to be limit as x approaches. The first one I'm going to say minus 3. I'm going to say from the left side, f of x. And then I'm going to put limit as x goes to minus 3 from the right side, f of x. So I'm looking at this over here, and from the left side, I see this is positive. Right, that's left side of minus 3. The next thing I notice is that to the right side of minus 3, I'm seeing it's negative. And these are going to be blow-up problems because the top and bottom are not simultaneously 0 at that value. So what does this tell me? I got a vertical asymptote, and that's when x equals minus 3. All right, let's keep moving. And I think I got another one too, right? The other one's going to be at 1. So limit x goes to 1 from the left. Again, we'll look at our number line to figure that out. And I want to do the limit as x approaches 1 from the right. So 1 from the left is positive. That's infinity. And 1 from the right, look up here, is negative. That's going to be minus infinity. So this tells me there's another vertical asymptote, and that's going to be x equals 1. Right, so two vertical asymptotes, x equals minus 3, x equals 1. From the left, it goes to plus infinity. I'm doing these over here. From the right, minus infinity. All right, pretty simple to do. Again, from the left, plus infinity. From the right, minus infinity. Again, work needs to be shown on both of these things over here. What's the work? It's basically a limit. All right, number 30, I think that's the last question. And it says slant asymptote. Well, that's done by a division. 2x squared. If you need to, just simply say there's no linear term by saying 0x plus 7. What times x gives you 2x squared? 2x. You get 2x squared plus 6x. You're going to subtract. It gives you minus 6x plus 7. What do you get now? Minus 6. Well, minus 6 times x is minus 6x. And then you get minus 18. This gives you 25. So if I rewrote the problem, what do you get? This problem, f of x, would look like 2x minus 6 plus 25 over x plus 3. What's a slant asymptote? This thing right over here. It's 2x minus 6. What does that mean? Y equals 2x minus 6. Do I see that? I do. It's letter E. And we're done. Thank you.